Tenemos el placer y el honor de tener a nuestro presidente, Stephen Barr, hoy aquí con nosotros. Steve es, como digo, el presidente de la Sociedad, presidente y fundador de la Sociedad de Científicos Católicos. Es también profesor emérito de Física de Partículas de la Universidad de Delaware. Él obtuvo su doctorado en Física en el año 78 en la Universidad de Princeton y su investigación se ha centrado principalmente en las teorías de unificación. Para los que no sepáis lo que es cosmología, el estudio del origen, básicamente origen del universo. En 2011 fue elegido como Fellow de la Sociedad Física Americana por sus contribuciones sobre las teorías de unificación, violación CP y variogénesis. Tiene numerosos escritos y ha trabajado durante mucho tiempo en la relación entre ciencia y religión. Es el autor del libro Modern Physics and Ancient Faith and the Believing Scientist, Essays of Science and Religion. Fue elegido en 2010 para la Academia de Teología Católica y ha recibido el premio, la medalla benemérita en manos del Papa Benedicto XVI. Pues, Steve.
I thank the organizers for inviting me to speak at this conference. Not only does it give me the opportunity to speak to you, but to visit this remarkably beautiful city. The title of my talk is, Can Consciousness Be Reduced to Physics? Carl Sagan, the well-known astrophysicist and science popularizer, once declared, I am a collection of water, calcium, and organic molecules called Carl Sagan. You are a collection of almost identical molecules with a different collective label. Strange as this assertion may sound, it expresses an idea that many of our contemporaries regard as so obvious as to be beyond dispute. The idea is called physicalism, and holds that all of reality, including the human mind, is ultimately nothing but matter in motion and therefore explicable in terms of physics. This philosophy has ancient roots, but in its modern form, it was inspired by a number of scientific developments, which is why it is sometimes called scientific materialism. One of those developments was Newton's discovery in the late 17th century of the laws of mechanics and gravity that now bear his name. Those laws were universal because they applied to all matter throughout the universe, and deterministic because they rigidly and uniquely determined how events would unfold from any given starting point. A classic statement of physical determinism was made by the great mathematician and physicist Pierre-Simon Laplace in 1814. He wrote, "To an intelligence which could know all the forces by which nature is animated, and all the states at some instant of all the objects that compose it, nothing would be uncertain, and the future would be present to its eyes." All of the fundamental mathematical laws of physics discovered in the 2 centuries after Newton were also deterministic, and this gave rise to the idea that the physical world is a completely closed system of cause and effect, with physical effects being entirely accounted for by prior physical causes. This is often called the principle of causal closure of the physical world. Despite the fact that nature seemed in this way to be in the iron grip of the laws of physics, many scientists and other thinkers continued to believe that life and mind must be exceptions and involve the operation of non-physical forces and principles. But with respect to life, this view was undermined by scientific advances in the 19th and 20th centuries that showed that the processes that go on in living things are based on the same chemical laws found in non-living things. And with respect to mind, it is hard to see how it could be an exception either if the principle of causal closure is assumed to be correct. Our thoughts, for example, our beliefs obviously affect our actions and therefore affect the physical world. So if physical effects can have only physical causes, our thoughts themselves must be just physical entities. As a science writer in the magazine Newsweek once put it, our thoughts are not mere will-o'-the-wisps, ephemera with no physicality. They are indeed electrical signals. It should be noted that the discovery of quantum mechanics in the 1920s showed that the laws of physics are not, in fact, deterministic and do not rigidly determine how events will unfold. Strangely enough, however, this has not shaken the belief of many philosophers in the principle of causal closure of the physical world, which now therefore seems to be supported more by ingrained intellectual prejudice than by anything science has actually discovered. The idea that minds are machines and thoughts are electrical signals started to gain ground, gain popularity with the development of programmable electronic computers in the late 1940s, after which the term thinking machines became popular. And now we have reached the point where machines can outthink us in activities whose mastery was once considered to require great intelligence, if not genius. For example, the chess-playing programs Stockfish and AlphaZero are now much stronger than the best human chess players. At the same time, rapid advances in neuroscience have demonstrated, sometimes in dramatic detail, the intimate connections between particular physical structures and processes in the human brain and particular mental phenomena. Many, therefore, regard it as axiomatic that neuroscience will eventually be able to account for every aspect of our minds. Francis Crick, co-discoverer of the structure of DNA, once wrote in a popular book, "You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. As Lewis Carroll's Alice might have phrased it, you are nothing but a pack of neurons." Now, one reason that physicalism is an attractive philosophy is that it promises a single, simple, and all-embracing explanation of reality. It thereby satisfies the natural desire of the human mind for unity and simplicity in our understanding of the world. This striving for unity and coherence was well described by St. John Paul II in his 1988 letter to the director of the Vatican Observatory. He wrote, "Unity involves the drive of the human mind towards understanding. When human beings seek to understand the multiplicities that surround them, when they seek to make sense of experience, they do so by bringing many factors into a common vision. Understanding is achieved when many data are unified by a common structure. The one illuminates the many. It makes sense of the whole. Simple multiplicity is chaos, and insight, a single model, can give that chaos structure and draw it into intelligibility." This striving for unity has been rewarded with enormous success in physics. Indeed, the whole trend of theoretical physics over the last 400 years has been toward an ever more unified conception of physical phenomena. First, Newton showed that the same laws govern terrestrial and celestial phenomena. Later, Newtonian mechanics was able to explain phenomena as diverse as the motion of fluids, the propagation of sound, and the flow of heat. In the 1860s, James Clerk Maxwell showed that electricity, magnetism, and optics are all aspects of a single force, now called electromagnetism. In 1905, Einstein showed that space and time form a unified four-dimensional whole, and that mass and energy are really the same thing. In the mid-20th century, quantum field theory showed that forces, wave phenomena, and particles are all manifestations of a single entity, quantum fields. Now physicists are closing in on a single unified theory of all of physics, which may well be so-called superstring theory. It seems very natural, therefore, to imagine that we are headed toward an even grander synthesis, in which not only matter, forces, space, and time, but all of reality, including mind itself, will be shown to be explained by a single theory of physics, a theory of everything. However, there is a danger in pushing any idea too far. It is possible to desire unity and simplicity of explanation so strongly that one is satisfied to obtain it on the cheap by ignoring or discounting what does not fall within one's scheme. Einstein said in a lecture in 1933, "It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate description or adequate representation of a single datum of experience." The fatal mistake of physicalism is precisely that it has surrendered a very important datum of experience, namely experience itself. Obviously, there can be no data of experience unless there is experience, and there can be no experience without a mind that can have experiences. In other words, consciousness. What I shall be claiming in this talk is that materialism or physicalism cannot account for consciousness. When I speak about consciousness in this talk, I am referring to what philosophers sometimes call phenomenal consciousness rather than functional consciousness. That is, I'm speaking about our incommunicable inner life, our subjective experiences, made up of our thoughts, feelings, desires, sensations, and so on. Not the externally observable behaviors and activities that may be associated with them. This inner life includes the things that Francis Crick so easily dismissed or demoted as our joys, our sorrows, our memories, our ambitions, our sense of personal identity, and our free will, and much else. It is strange, but sometimes we tend to be so focused on external physical reality that we forget about this inner reality. We literally forget ourselves. There's a story about the ancient Greek philosopher Thales, who lived about 600 years before Christ. It is said that he was so absorbed in studying the stars that he fell down a well. Some modern scientists have a similar problem. They're so focused upon the external world of physical objects, they forget their own inner life. Or they become so used to thinking about material things and the relationships among them that they lose the ability to conceive of anything, even their own thoughts, as anything other than material things, or as mere shadows of material things. The Nobel Prize-winning physicist Eugene Wigner once wrote that the enormous explanatory success of the physical sciences has contributed to this forgetfulness. He wrote, "The brilliant successes of physics and chemistry overshadowed the obvious fact that thoughts, desires, and emotions are not made of matter." The eminent cosmologist André Linde wrote about this at more length in one of his research papers. Very unusual, it's very rare to find in physics research papers a philosophical reflections, but Linde, in an important cosmology paper, wrote this long paragraph, which I will read to you. He wrote, "The standard assumption is that consciousness, just like space-time before the invention of general relativity, plays a secondary subservient role, being just a function of matter and a tool for the description of the truly existing material world. But let us remember that our knowledge of the world begins not with matter, but with perceptions. I know for sure that my pain exists, my green exists, and my sweet exists. I do not need any proof of their existence, because these events are a part of me. Everything else is a theory. Later, we find out that our perceptions obey some laws, which can be most conveniently formulated if we assume that there is some underlying reality beyond our perceptions. This model of the material world obeying laws of physics is so successful that we soon we forget about our starting point and say that matter is the only reality, and perceptions are nothing but a useful tool for the descriptions of matter. This assumption is almost as natural, and maybe as false, as our previous assumption that space is only a mathematical tool for the description of matter. We are substituting for the reality of our feelings the successfully working theory of an independently existing material world. And the theory is so successful that we almost never think about its possible limitations. Now, before proceeding further, it's important to make a distinction in order to avoid a possible misunderstanding. The issue I am addressing in this talk is not whether consciousness is a natural phenomenon, but whether it is a physical phenomenon. That is, the kind of thing that can be accounted for by physics. Physicalists claim that it is. What Linde and many others have suggested is that consciousness, while being a feature of the natural world, just as matter is, may be something just as real and fundamental as matter, and not reducible to it. Some might object that if matter and consciousness are both features of the natural world, then there ought to be some unifying explanation of both. That is certainly a reasonable supposition. But a unifying explanation of two things, A and B, does not necessarily have to reduce A to B or B to A. Consider an example from within physics. We have an enormously successful and well-established theory of electromagnetism. It gives a unified understanding of both electromagnetic fields and electrically charged particles. But it treats them as distinct and equally fundamental realities. It does not say that electromagnetic fields can be reduced to or are composed of charged particles, nor does it say that electrically charged particles can be reduced to or are composed of electromagnetic fields. Rather, the theory shows how the two realities are related to each other. There are equations that describe the effect of charged particles on electromagnetic fields, called Maxwell's equations, and there is an equation that describes the effect of electromagnetic fields on charged particles, called the Lorentz force law. In the passage I quoted from André Linde, he makes use of a different example from physics, namely how Einstein's theory of gravity, general relativity, treats both material particles and space as equally fundamental realities without trying to reduce either one to the other. But even if we were to grant, for the sake of argument, that a unifying explanation of two things, A and B, must reduce one of them to the other, which one should be reduced to which? The philosopher Georges Rey has written, quote, "Any ultimate explanation of mental phenomena will have to be in non-mental, that is material, terms, or else it won't be an explanation of it." However, one could just as well turn this argument around and say any ultimate explanation of material phenomena will have to be in non-material terms, that is mental terms, or else it won't be an explanation of it. So there is no a priori reason to expect that all mental phenomena, including consciousness, must be reducible to matter or explained by physics, as the physicalist assumes. To be sure, there are very good reasons to suppose that consciousness is intimately connected to matter, and that the two together form a single integrated system we call nature. For example, consciousness only seems to arise when certain kinds of physical structures are present, at least nervous systems and probably brains. Few people would take seriously the idea that inanimate objects or plants, or those animals that lack nervous systems, such as sponges, are endowed with consciousness. Moreover, we know that physical changes in the brain result in changes in conscious experience in ways that are somewhat predictable. For example, a lower than normal concentration in the brain of the molecule dopamine can lead to the subjective experience of boredom or apathy. Damage to a certain small area of the visual cortex, called V4, can strip color from one's visual experiences. The electrical stimulation of a certain tiny region of the brain produces mental states ranging from mild amusement to hilarity. As reported by researchers, quote, "At low currents, only a smile was present, while at higher currents, a robust contagious laughter was induced." It seems justified, therefore, to say that physical events naturally cause conscious effects, and that matter in certain configurations naturally causes consciousness to arise. The question, however, is whether this natural causation is physical causation. That is, the kind of causation that physics can explain. There are strong, even compelling, reasons to say that it is not. To understand this, one must first ask, how does physics explain things? The answer is that physics explains phenomena by showing how they follow from the basic laws of physics. In particular, physics explains how a physical cause produces a physical effect by showing that the effect can be derived from the cause using the equations that express the basic laws of physics. For example, if one places a cup of water in a microwave oven and turns it on for a sufficient period of time, the water will boil. This can be explained by showing how the oscillating electric fields field, the oscillating electric field of the microwave radiation, pushes around the electrically charged particles in the water molecules and imparts energy to them, how this energy is dissipated as heat due to collisions among the molecules, and how this causes a phase transition in the water. All of this follows from the equations of electromagnetism and other known laws. That is because both the cause, the microwaves, and the effect, the water boiling, are configurations of and changes in matter that are describable by mathematical variables that appear in those equations. Now consider, by contrast, how lowered dopamine levels in the brain cause the feelings of apathy or boredom. How the dopamine molecules interact with the various other physical constituents of the brain and the consequent effects on brain functioning can certainly be accounted for by physics, in principle, if perhaps not yet fully in practice. But the feelings of boredom and apathy that result are something quite different. Those feelings are not calculable using the equations of physics, like the positions of atoms within a dopamine molecule. There is no boredom or apathy variable appearing in the laws of physics, nor can one measure and thus quantify boredom and apathy in the same way that one measures the position of atoms. One can, of course, observe and measure physical effects of boredom and apathy, such as expressions on a face, or the sounds of groans, or tapping fingers. The feelings of apathy and boredom, however, are part of the inner subjective experience of the person having them, just as his or her pain, green and sweet are, to use Linde's examples. Similarly, there can be little doubt that physics and chemistry can explain how the cone cells in the retina react to electromagnetic waves of different wavelengths and encode that information in signals that are sent up the optic nerves, and how the cells in the V4 region of the visual cortex allow the brain to interpret this information and distinguish different wavelengths of light. But the private, subjective, incommunicable experience of green is something altogether different. The philosopher Frank Cameron Jackson invented a famous argument concerning sensory experiences, which philosophers call qualia. He considered a hypothetical person whom he named Mary, who knows everything there is to know about the laws of physics and about human biology, including the physiology of human color perception, but who was raised from birth in a completely black and white environment and had therefore never experienced color sensations. If she then saw the color red for the first time, would she have learned something about reality she had not known before? Obviously, yes. But that something that she learned isn't something she could have derived from her previous complete knowledge of physics and human physiology. There is something about the world of experience, therefore, that eludes the grasp of the equations of physics. One can make a broader argument along the same lines. Even a complete description of any physical system or entity, down to the configurations and changes of its most basic constituents, whether they are elementary particles such as electrons and quarks, or are superstrings or something else, and a complete knowledge of the equations of physics would not be enough to reach any conclusion by mathematical and logical deduction about whether that system or entity was experiencing anything. That is, whether it had consciousness. For example, it might be foolish and perverse of me to deny that my dog has consciousness and subjective experiences. But if I did deny this, I would not be contradicting anything we know about physics and chemistry, nor would I be involved in any logical contradiction. A normally functioning dog that is running around and barking, but is utterly devoid of consciousness and subjective experience, may be contrary to the order of nature, that is, to the way the universe actually works, but it cannot be shown to contradict the equations of physics. Arguments along these lines have been made by several eminent contemporary philosophers, including Saul Kripke, Thomas Nagel, and David Chalmers. They point out that one can conceive of a universe that had the same, a hypothetical universe, that had the same laws of physics as ours, and that contained living beings that were physically constituted just like human beings or other animals in our universe, and yet utterly lacked consciousness. There seems to be nothing logically or metaphysically impossible in the idea of such a universe. In our universe, it does seem to be the case that beings that are physically constituted in certain ways have consciousness, but this cannot be shown to follow by logical necessity from the laws of physics. It is not only some eminent philosophers who have made this point, but some eminent physicists as well. Some years ago, the theoretical physicist Edward Witten, regarded by many of his colleagues as the most brilliant physicist of his generation, was asked by an interviewer whether he thought humans would ever know the ultimate laws of physics, and whether, if that day came, anything would still remain mysterious. Witten responded that he thought several things would likely remain mysterious, including consciousness. These were his words. Quote, "I tend to think consciousness will be a mystery. That's what I tend to believe. I tend to think that the workings of the conscious brain," he's talking about the human brain, "the conscious brain will be elucidated to a large extent, that biologists, with perhaps physicists contributing, will understand much better how the brain works and why something that we call consciousness goes with those workings, I think will remain mysterious. Perhaps I'm mistaken, but I have a much easier time imagining how we'd understand the Big Bang, even though we can't do it yet, than I can imagine understanding consciousness." He meant understanding it from physics. When pressed by the interviewer, who was evidently not pleased with his answer, to define consciousness, Witten responded, "I am not going to attempt to define consciousness in a way that is connected to the fact that I don't think it will become part of physics. I am skeptical that it's going to become part of physics." Erwin Schrödinger, one of the founders of quantum mechanics, wrote, "While all scientific knowledge is based on sense perceptions, the scientific view of natural processes formed in this way lacks all sensual qualities and therefore cannot account for the latter." In an interview, he also said, "Consciousness cannot be accounted for in physical terms." At this point, a question naturally arises. If physics is not a complete account of nature, as the physicalist believes that it is, shouldn't there be some hints of that incompleteness coming from physics itself? If something is incomplete, shouldn't there be gaps or loose ends or ragged edges in it pointing to its incompleteness? And yet, as physics has progressed, its theories appear ever more tightly integrated and rounded off, so to speak. It appears more and more that the ultimate fabric of physical theory will be seamless, woven in one piece from top to bottom, if one may borrow a scriptural image. There is, however, one strong indication from physics itself of its own incompleteness. It was pointed out in 1930 by John von Neumann in his classic book, The Mathematical Foundations of Quantum Mechanics. Quantum mechanics, which is the foundational grammar of all physics, posits two kinds of entities: systems, which are observed and measured, and observers, who make the observations and measurements. The equations of physics describe systems, but not observers, at least not fully. If one tries to stretch the equations to describe the whole process of measurement, including both the system and the observer in their totality, one runs into a fundamental problem. The problem is that the equations of quantum mechanics only yield probabilities of various possible outcomes of measurements, whereas a measurement, to be such, must yield a definite outcome. Therefore, if everything is described by the equations, then only probabilities can result from the calculations rather than any definite outcome, meaning that no measurement ever happens. Am I competing with that sound? Could it perhaps? Is it possible to stop that sound? Okay. Okay. Thank you. This is the classic measurement problem. Again, to reiterate, the equations only yield probabilities, not definite outcomes. But measurements always must have a definite outcome. Therefore, the equations cannot describe everything that goes on in a measurement. Some eminent physicists have argued that the only way out of this conundrum is to say that something about the observer, in particular his or her knowledge and consciousness, is not reducible to physics and cannot be included in its mathematical descriptions of the world. For example, Sir Rudolf Peierls, a leading 20th century physicist, said, "The premise that you can describe in terms of physics the whole function of a human being, including its knowledge and its consciousness, is untenable. There is still something missing." In a famous essay on the measurement problem, the physics Nobel laureate Eugene P. Wigner, whom I quoted earlier, wrote that materialism is not consistent with present quantum mechanics. Commenting on this, he said, "It will remain remarkable in whatever way our future concepts develop, that the very study of the external world led to the conclusion that the content of the consciousness is an ultimate reality. That is not something reducible to physics." These conclusions about the implications of quantum mechanics are very controversial, and most physicists would be very reluctant to accept them. Nevertheless, it does seem that fundamental physics is pointing to its own radical incompleteness. So far, and that actually is not as controversial. So far, the discussion has been about physics and philosophy, but some readers may suspect, or listeners to this talk in person or by live streaming, may suggest that lurking behind this discussion that I'm giving is religion. They would be partly right, but several points should be made in this regard. First, many of the philosophers and physicists who have doubted or denied the sufficiency of physics to account for consciousness are not religious. That is the case of almost all of those whom I have quoted in this talk, including the physicists Schrödinger, Rudolf Peierls, Eugene Wigner, Andre Linde, and Edward Witten, and the philosophers Frank Cameron Jackson, Thomas Nagel, and David Chalmers. None of them are religious. Second, Sol Kripke, I think is. Second, biblical religion, and Catholicism specifically, do not teach anything about consciousness and whether it is reducible to physics. It would be perfectly orthodox for a Catholic to say that lower animals, despite possessing consciousness, can be entirely understood in material terms, in terms of physics. It is not consciousness that is of doctrinal significance to the Catholic Church and Christian tradition, but rather the distinctively human powers of rationality and freedom, which the Church, as well as a long philosophical tradition, claim to be not reducible to the merely material. So nothing is directly at stake for Catholic doctrine in the question of consciousness. And yet it does have relevance to religion in an indirect and negative way. For the irreducibility of consciousness to physics is enough by itself to refute physicalism. And physicalism is perhaps the greatest intellectual block to religious belief today. By its sweeping claims, physicalism rules religion completely out of court. If nothing but physical stuff exists, then obviously God and the human spiritual soul cannot exist, nor could many of the other realities that Catholic doctrine and Christian tradition speak about. Most of those today who claim that being scientific means being an atheist hold that view because they think that science somehow points to the truth of physicalism. And yet nothing is more unscientific than physicalism. For science is based on empirical facts, and there is no empirical fact more basic or more evident than that we are conscious, a fact that physical science is, by its very way of proceeding, powerless to explain. Thank you.
Thank you very much, Steve, for this interesting and inspiring talk. I think we have time for at least a couple of questions. I'm sure the audience, Javier? No. Yes, it's coming.
Thanks, Steve, for your awesome talk.
Thank you.
I completely agree, so I'm not against you. I just wanted to raise the question of consciousness being an epiphenomenon. So you explain how consciousness cannot be reduced to physics, but I guess some philosophers of physics, philosophers of nature would say, okay, perhaps consciousness is something different from physics, from matter, but it does nothing. So it's like it's an epiphenomenon. It hasn't causal power in itself. And specifically, they would say that perhaps in thoughts, there are causal relations between thoughts, but consciousness for sure cannot impinge on the material basis. So that's the problem of interaction. So that's Descartes' problem. What would you say to that? What's your take on that?
That is a very good question, and it makes me regret that I did not address it in this talk. But you've given me the opportunity to do so. A good answer to that, I think there's more than one good answer, but a very good answer to that is given by an argument of a philosopher and physicist, an Israeli philosopher and physicist named Avshalom Elitzer. At least that's where I heard the argument. Avshalom Elitzer points out that when we talk about our conscious experiences, so suppose I talk about whether my happiness or my ambition or my pain or my green or my sweet, or when I am talking about my conscious experience, my talking involves physical activities, the motions of matter, my vocal cords and mouth and so on. But clearly, I cannot be talking about my subjective experiences and my consciousness unless it must be my subjective experiences and consciousness that are informing what I say. And so my consciousness, my subjective experiences are causing my speech or my writing or my expression. And so that, I think, is proof that it's not merely epiphenomenal, that it has a causal effect. So anytime you talk about your consciousness, you are disproving your consciousness is merely epiphenomenal. A second argument, which is more a plausibility argument, is if our consciousness, if our feelings, emotions, thoughts, and so forth did not have any effect on the world of matter, then why did they evolve? I mean, it's clear from an evolutionary point of view that these feelings actually, if they didn't have any practical effect, they would have no survival value to have them, and therefore they wouldn't have evolved. So why are these epiphenomena there if they serve no evolutionary purpose? And if they're merely epiphenomena that have no causal efficacy, they can have give you no evolutionary advantage. And so that's another argument.
Werner Heisenberg wrote in Physics and Philosophy that Aristotelian hylomorphism is, in his mind, the philosophy more suited for dialogue with physics, where the whole is more than the sum of the parts. There is also the relation or the order among parts, which is immaterial, in which is form. So do you think that perhaps hylomorphism, sense consciousness is not a physical concept, as you said, and all these people, but a philosophical concept? Do you think that it could help for your discourse and your positions the idea of form besides matter?
Which philosophy did Heisenberg say?
Hylomorphism. Aristotelian hylomorphism.
Right, hylomorphism.
Materia and form.
Yeah.
Physics and more than physics.
I'm not a philosopher, so my opinion on that is worthless. I personally don't know what to think about hylomorphism. I have, as it is held by some Aristotelian philosophers, and as they explain it, I have some doubts about it, or some difficulties with certain versions of that idea. Let me put it that way. But my opinions on the subject are of no value.
Okay. There is a question on the chat, but I think we are running out of time, so I prefer to stop here. Let's thank again Steve for this talk.